This is a laboratory power supply. It's an AIM TTi EX355R. It is 35 volts, 5 amps max. I found this in the garbage. I don't know what's wrong with it. Let's find out. Let's turn it on and see what happens. Absolutely nothing. Okay, let's look inside. No obvious burnt components. Let's look at the bottom side. Okay, since it doesn't seem to turn on at all, let's start from the power supply section. Here we have the mains input connector, and here we have a bunch of filtering with capacitors and inductors. Here we have the input fuse, that one is not blown. Here we have the connectors that goes to the power switch. Some more filtering, and then it goes to the full bridge rectifier. I think this is a good place to start measuring. Let's see if we get a DC output from this full bridge rectifier. Here we have the AC input, and here we have the DC output. Let's turn it on. Okay, so we definitely have a DC output. Okay, so the next step would be to see if there's any power going to the control board. So there's no label on the connector between the main PCB and the control board. So I will just measure every pin and see if there is any reasonable voltage, like 3 volts or 5 volts or something. Seems to be no power to the control board, so the problem is probably on the main PCB. Let's disconnect the control board and redo the measurement just to make sure that the control board is not shorting the voltage out. Now we have 5 volts, 12 volts. Since there's voltage on this connector when the control board is not connected, it could be something wrong with the control board. So let's take it out. So the control board seemed to be pulling the voltages down somehow. Let's start by looking for dead shorts on the control board where it connects to the main board. So I will just go through every pin here and see if there's any dead shorts here. Okay, so there's a dead short between the pin labeled 0 volts and the pin labeled reverse mid OPA. That might be the way it's supposed to be, I'm not sure. Let's come back to that later. Okay, so there seems to be a dead short between 7.5 volts and 5 volts. That is definitely not the way it's supposed to be. Okay, let's detach the control board. It seems that the short is not on the control board. Okay, it's on the main board. Okay, let's try to figure out what those pins are connected to. Should be these two, which are obviously connected together on the PCB. So they are definitely supposed to be shorted together. And that's a bit weird. Why would you connect those two together? So this connector can apparently be mounted in 2 ways, since this pin header has more pins than the socket. So it could be mounted like this as well. If it were connected like this, let's see on the control board which pins will be shorted now. So instead of 7.5 volts and 5 volts, it will be shifted one step to the left. So 0VA and 0V. That would make a lot more sense. Okay, let's see what the outermost pins connect to. See which one is more likely to be used. Okay, let's start with this one and follow the trace. Goes to this via, which is connected to this connector, which is not used on this unit. Okay, let's continue with the second pin. Follow the trace. Goes to this via, which is this one. We follow the trace. It goes to this capacitor. Now this capacitor would not have been mounted if this node were not supposed to be used. Okay, so everything seemed to suggest that this connector should actually be mounted like this instead. Okay, let's see what happens. Okay, so it was definitely incorrectly connected. Let's test it out and see if it works. The current limiting is working. It's working. It sure makes you wonder how this happened. Seems like someone disassembled a working unit, disconnected the control board for some reason, reconnected the control board incorrectly, assembled the unit, concluded that out of sheer coincidence the unit is no longer working, and threw it away. Good for me.